We will continue our investigation of rolling balls down slopes. Today we will set up a system that helps us to answer our focus question. How does the starting position affect the speed of a ball rolling down a ramp? We are designing a system to find out if the starting position on the ramp affects the speed of a ball. We are going to release two balls at different starting positions on the ramp. The balls will need to be the same mass, so we're going to use two large balls. The balls will need to start at the same time, and the distance they travel must be the same. So here is how we will set up the procedure. Step 1, we will take two ramps side by side so that the bottom edges are even. Step 2, we will tape a meter tape to the ground. So the 0 is at the bottom of the ramps. We will measure 50 centimeters away from the bottom of the ramps and place the cardboard at this spot. The cardboard will mark the finish line. Step 3, we will place one large ball on the ramp so the front of the ball lines up the line at position 5. So here's position 5 at the line. We will place the second large ball on the other ramp at position 2. Step 4, we will release both balls at the same time. We will watch and listen to determine if the balls reach the finish line at the same time or if one finishes first. Step 5, we will record the data in our notebook. We will repeat the process 2 more times. So we'll have a total of 3 different times, because when we are doing science, we need to do things several times to make sure that the outcome is real. Trial number 1. You can see that the ball that started at spot 5 was the clear winner. Trial number 2. Again, ball that started at spot 5, the clear winner. Trial number 3. And again, the ball that started at spot 5, the winner. As you could see, the two balls were not traveling at the same speed. The ball that started at position 5 went faster. We know this because that ball reached the finish line first. The higher the starting point at which the ball starts, the faster it travels. The ball that started at position 5 reached the finish line before the same ball starting at position 2. The ball that travels the distance in the shorter time is faster. So our results show that the starting position makes a difference in how fast balls roll down a runway. Gravity is the force pulling the ball down the ramp. The higher on the ramp that a ball starts, the faster it goes. So the greater the distance above Earth's surface an object is, the more potential it has to get going faster. The position above Earth's surface determines an object's potential energy. So the higher it is, the more potential energy it has. Then the potential energy of a ball is transformed into kinetic energy. That is the energy of motion as the ball is pulled down the ramp by gravity. The higher the ball's position, the greater the ball's potential energy, which changes into kinetic energy as the ball rolls down the ramp. So now I want you to please answer the focus question. How does the starting position affect the speed of a ball rolling down a ramp? Please use evidence from this investigation. And I would like you to please post this on Seesaw or by email. Thank you. Next, we're going to read an article called What Causes Change of Motion? This article will give us some information about the concepts of motion, force, gravity, and speed. When we are done reading the article, I want you to be able to answer these 3 questions. Number 1, how do you get an object to start moving? Number 2, how do you get a moving object to stop? Number 3, starting and stopping are 2 changes of motion. What are some other changes of motion? What causes change of motion? A wagon is a useful tool for moving a large load around more easily. Suppose you have a wagon sitting motionless with a load of watermelons in it. To take the watermelons with you, you will need to put the wagon into motion. How can you do that? You have 2 options. You can get behind the wagon and push it, or you can get in front of the wagon and pull it. The wagon will not move by itself. The wagon will move only if a force acts on it. Pushes and pulls are forces. Red arrows show force. Forces make things move. Blue arrows show direction of motion. So pushes and pulls are forces. The red arrows. Forces make things move. Blue arrows. If you apply a force to get the wagon moving, it will keep rolling. Oops! You don't want the moving wagon to crash into something. How can you stop it? It takes force to change the motion of a moving object. Again, you have 2 options. You can get in front of the wagon and apply a pushing force to slow or stop its motion. A, push to stop. Or you can get behind the wagon, grab onto it, and apply a pulling force to show its motion. B, pull to stop. To bring a moving object to a stop, you need to apply a force in the opposite direction of the motion. To change the motion of an object, a force is needed. Each wagon was moving to the right, blue arrow. A force in the opposite direction, red arrow, caused each wagon to stop. If the rolling wagon of watermelons is moving too slowly, how can you make it move a little faster? You can use more force. If you get behind the wagon and give it another push, the wagon will move faster. The wagon will move faster if you get in front of it and give it another pull too. More force in the same direction will make the wagon move faster. If the wagon starts moving too fast, you can use a push or a pull to slow it down. Force can be used to change the speed of a moving object. If the wagon starts to roll to one side, how can you make it roll straight again? You need to apply a force, but this time you need to apply a force to the side of the wagon in order to change its direction of motion. Any change of motion of an object, such as starting, stopping, change of speed, or change of direction, requires a force. A force applied to the side of a wagon will change its direction. Gravity. Think about a ball resting motionless on a table. A gentle push on the ball will put it into motion. The ball will roll across the table. What will happen when the ball comes to the edge of the table? The ball will roll off the edge and fall to the ground. The ball's motion changes when it rolls off the edge of the table. It moves in a different direction and starts to move faster. So gravity is pulling on the ball. You push it, it moves to the edge of the table, and gravity makes a ball fall to the ground. What causes this change of motion? That's right, force. What force makes the ball move toward the ground? The force that makes the ball fall to the ground is gravity. Gravity is a pulling force between 2 objects, and it draws them toward each other. The bigger the objects, the stronger the gravitational force between them. Earth is a huge object, so it pulls strongly on all other objects. It is the force of gravity that pulls objects to Earth's center. When you toss a basketball through a hoop, gravity pulls the ball to the ground. If you return the ball to the flat tabletop, it will again rest there motionless. Why doesn't the ball fall to the ground? The ball doesn't move because the forces acting on it are balanced. There are two forces. First, the table is pushing upward on the ball. Second, gravity is pulling the ball downward toward Earth's center. When two equal forces act on an object in opposite directions, the forces are balanced. When the forces acting on an object are balanced, the object's motion does not change. But what happens if you tip the table? The ball starts to roll down the table. For the ball to start moving, a force must act on the ball. Tipping the table unbalances the forces. The forces are no longer opposite and equal. Gravity pulls the ball downhill toward Earth's center. The round ball rolls across the table, over the edge, and down to the ground. When you're on a slide, can you feel the moment when the forces become unbalanced and gravity pulls you down? The force of gravity pulls the ball to the ground. So please answer these 3 questions and submit them on Seesaw or by email. Number 1, how do you get an object to start moving? Number 2, how do you get a moving object to stop? Number 3, starting and stopping are 2 changes of motion. What are some other changes of motion?